Okay, so before we start, as usual, anything from your side? So this is week 11, right? We still have 3 more weeks, right, to go. All right. Everything good, lah. Okay, good to know. Oh, everyone already in Raya mood. Hey, sleepy young people sleep so much. Hey. Okay, so if nothing from your side, let's look at our new topic today. Right. See, yeah. Okay, so this will be on topic 6. All right. So this will be the continuities from our previous lectures. On topic 5, we talk about how do we examine for the unit root of a series, right? So let's look at this. Okay, so now we are in the second half of our discussion. So remember TSA, basically we look at 2 branch. Okay, so firstly more on so firstly more on forecasting. Okay. Okay, so we concern more on univariate model. Okay, so we believe that to study the behaviors of the series, simple rules is that we look at the past performance. Now, the second half of our course basically looking at examining relationship between variables. So we would like to quantify the relationship between sets of variable. So in this case, right, we have 2 choice. All right. So we start with a model that trying to relate, right, a variable y with a set of independent variables. So we would like to quantify the relationship between the two or more than 2 variables. So this will be what we are going to do. Okay, so in our topic 5, we learn that the time series properties for each data. Okay, time series properties, which means what? On the stationarities of the series. Okay, so we have to ensure that all our data, they are stationary, okay, because we are using regression. So this is one of the crucial assumption. Simply because we are using regression analysis. Okay, so once you use a regression analysis, it's very important for you to ensure that the data is stationary. Okay, so that is so far our concept. Okay, what we have learned so far. Okay, and we believe that even though we believe that in the beautiful world or in the theoretical world, we wish to see that all our data, time series data, they are stationary. But in practice, this violation of the assumption generally is what we see. Most of the time we see that in practice, when we study our sample data, they are not stationary. So again, you have the notion between population versus sample. Okay, so population means the beautiful world in the theory. So you want stationary. But against the odd, you will see that come to practice, because of our limitations, our sample size can be small, right? What we see is that they are non-stationary. All right. So today, our topic 6, focusing on this issue. So what happens if, let's say, in practice, dealing with your sample data, let's say you want to look at your FYP, you study using time series data, you find that, what happened when we see that our sample data, they are non-stationary. So because we worry about what? Remember, spurious regression problem. It is the case situation whereby you might get a very beautiful regression result, but it can be misleading in a way. So how should we avoid about this? Okay, so today's focus when we talk about topic 6 is dealing with this issue. So we ask what happened if, right? When come to practice, when we study a relationship between the two, let's say we want to model relationship between X and Y, and we figure out that, oh yeah, our sample data do not fulfill what the assumption require, which is the stationarities. Okay, which is pretty common when you're trying to look at your data, right? Generally, we see that non-stationary is a typical pattern. Okay, so last week we learned several techniques to formally examine the stationarities of series. We look at the Dickey-Fuller test, we look at the augmented Dickey-Fuller test, we have the stationary test like KPSS and so on and so forth. There are varieties of choice that you can have, right? Helping you to determine whether the series is stationary or not. So if it's stationary, then happy ending lah. So you proceed with your FYP. Okay, so you regress and then you draw inference, you look at the size and significancy, and then you submit and then you graduate. Right now, the problem here is that what happened if, let's say, you conduct your unit root test, you find that, oh yeah, your series is not stationary. Okay, so that is one of the issues that we are going to examine today. What happened if the data, they are non-stationary? So in these lectures, I'm going to introduce you to a new concept called co-integration. Okay, so this is basically means long run core movement. Okay, so we want to look at second assumption frequently used in time series analysis. First is on the stationary, second is the co-integration. So we are going to learn about this concept and how this concept can help us in terms of regression analysis. So we will be looking at a very simple case by examining a simple model. So let's start with a bivariate model that we concern more on relationship between two variables first. Okay, so next topic, we can easily extend this model into other axes. More axes can be coming in that is multivariate, but for today's lectures, because we just want to grab this concept first, we look at a simple case whereby we are focusing on two variables. So let's look at what happens if we want to examine the relationship between two variables. Okay, so that is the scope of our discussion today. All right. So let's look at the key focus for today's discussion. As usual, we have 3 discussion. Remember, the key concept here is to look at the concept of co-integration. Co-integration, our general or loosely understanding this term co-integration means there is a long-run core movement or long-run relationship. So we expect there is a long-run relationship between sets of variable. Okay, so that is what we see. Okay, so let's look at how we go about this topic. All right. Firstly, I would like to introduce to you this concept first. All right. So we want to understand what is this co-integration about, okay, and what is the implication on our regression analysis. Okay. So secondly, right, once we understand this concept, so this concept basically implies that there exists a long-run relationship between two variables, right? So the second half of our discussion, we will focusing on examining this long-run relationship. So how do we know there is a long-run relationship between the two variables? Okay, how do we know, in specific, how do we know there is a co-integration between these two variables? Okay, so if we see there is a long-run relationship between these variables, so what does it mean? So what? These are the questions that we want to examine. And lastly is that, okay, if we see there is a long-run relationship, so how do we model them? Okay, so this is what it means. So what is, and then we look at the implication. So the secondly, how to detect integration or long-run relationship between sets of variables. So we're focusing on this test called Engelbringer test, right? Thirdly, if there is long-run relationship, how should we model the relationship? Okay, so in particular, we look at a model called error correction model. So what's so special about this model is that this model able to capture the long-run relationship plus the short-run relationship, these two together in one single model. So this is basically our roadmap. So we look at the concept first, and then we see how we learn how to detect it. Once we figure out there is a relationship, then we ask, how do you model it? Right, so these are the C3 combo that we're going to study in this topic. Okay, so let's look at this. All right, so most of the time, what do you see is that in econs or finance, right? So when we learn about all the theories, right? So remember, theories is pertaining a long-run phenomena. So whatever theory that you learn in econs or finance, or talking about human behavior, it basically talk about the behaviors in the long run. It is just a long-run concept. So this is a reason why normally you will see that once you go try to apply the theory in practice, you find that how come in practice the theory seems not whole at all? So it seems that the theory is not able to explain well the current situation. So one of the reason is because theory is a long-run concept. In practice, maybe right, the time spent is not long enough that we are heading towards long run, but not long run yet. So that is the question. Okay, but now, regardless whether we are talking about long run or short run, now what if, let's say, we would like to examine a long-run relationship between a set of variable, or you want to examine whether a theory still remain relevant today or not. So let's say you're interested to study about the long-run relationship between a set of variables. So how do you start with? So now, what happened here is that you will see that most of our data in practice, right, they are non-stationary. So in this case, you need to first different them. Okay, so that is basically what you observe in practice. Okay, so now let's look at some example. I say in econs and finance, you see that most of time when you talk about the econ and finance theory, you deal a lot with a stable long-run relationship between a set of variables. For example, if you talk about consumption function, we believe that in the long run, how much you spend, it depends on your income lah. Okay, so price in the goods market depends heavily on your salary or wages. right? And then there is a long run relationship between price in the local market and price in the overseas market. So this is a law of one price or purchasing power parities. So those are what we call a theory lah, that help you to understand the real world. So now if we wanted to examine all these theories, so let's say we want to see, hey, is this theory still hold today or what? You probably would like to look at the long run relationship. Okay, so that is basically the story. Okay, so now let's look at this example. Okay, so we would like to look at Keynesian consumption function. Okay, let's look at one example first. Okay, so look at one example. Okay, so let's say we are interested to examine a consumption function. So consumption function is a simple function, basically say how much you spend depends on how much you earn. Okay, very simple. It's a very simple concept. All right. So typically, before you start your analysis, you would like to think about what's so important to study this? Why do you want to study this long run relationship? Why do you want to examine this consumption function? There must be some rationale behind this model. Okay. So recall that from your elementary economics subject, like for example, principle of macro, principle of micro, or look at simple macroeconomics paper or economics paper. So you know that when we're talking about managing a countries, okay, so every country's interested to find out, okay, or to know what is a secret, what is the secret of making income, generate income. So you would like to know about the secret behind generating the wealth of nation. So why some countries they are very rich, why some countries they're not are poor. Let's say for example you're interested to find out this. Okay, so from your basic economics paper, you learn about an identity called income of a nation is determined by C plus I plus G plus X minus M. Very simple. This is your household consumption. This is your firm's investment. This is your government spending. So this part will be more on international trade, that you engage more on the export and your import, how much you export and how much you import. So looking at this national income identity, what does it mean? So this identity basically tell you a secret, the wealth of nation, how a country to become a rich country, right? This is the secret sauce. So on your right hand side, what do you see? You have the four components C plus I plus G plus X minus M. So in this case, if you zoom in further, you see that this is what? This is domestic market. This is international. So how do you make a nation rich? Very simple. The secret sauce is here. Spending. Okay. Who going to spend? You, which is the household. Who going to spend? Businessmen need to spend. Who going to spend? Government have to spend. Okay, so the secret sauce of making money for countries is very simple. you need people to spend. If everyone is busy saving money, then your countries will not progress. Okay, so managing countries is different, right? It's different from managing a household or firms. So your mom always scold you, why you still keep on spending money, right? You being scolded. But from the country perspective, government want you to spend, okay? Because if you want to spend, there is a demand there. So if you want to spend, you want to buy goods, you want to buy services, so business will invest so that they can supply all these things to you. And when the business is doing well, the government will step in. They're going to provide infrastructures to make this a more conducive business environment, and as well as taking good care of the welfare of Rakyat. So in this case, definitely on the right-hand side, right, you see people need to spend. The people is what? Either it's household, either it's firms, or either it's government. So in this case, when you learn about macro paper or economics paper, you're trying to learn about all type of policies that encourage people to spend, right? So you have the monetary policies engaging with interest rate, for example. Okay, so it's a way for a government to manipulate the way for you to spend your money. So if the economic is not doing well, so the government trying to reduce the interest rate so that you won't save more money in the bank, you're going to spend, right? So this is how it boosts the economy. Okay, so that is a simple facts that you learn. Okay, so if you're doing FYP, normally these are the things that you see lah. You explain in your background or your studies, right? This is how the economics works. Okay, so in this case, right, we know that how people spend have an impact on bringing the wealth of the nation. Okay, now let's say we're zooming in. We would like to pay attention to these things. Okay, so you are interested to looking at the consumption function. So the consumption function, you look at the theory. Let's say we following the Keynesian school of thought. So Keynes consumption function, he basically says it very simple. Theory says what? Theory says consumption is a function of income. So no matter how much you earn, right, your spending behavior will not change much. This is basically what Keynes believe, right? So this is the theory. So you use this theory as a way to understand the real world, because theory is a cumulative knowledge, right? So Keynes says that there is a relationship between the two, right? But theory never tell you how much. Okay, so now you would like to examine this. You would like to look at the consumption pattern of Malaysian. Okay, so let's say you're going to use regression analysis to quantify this function. Okay, so what you do, trying to get the consumption data. Okay, and then you use regression analysis. So bring the time series data in. So you want to look at this number, beta value. So the beta value tell you what? How much your consumption will change if your income change. Okay, so this beta in theory, this is what we call marginal propensity to spend, MPC. Okay, so the policymaker like to look at this MPC, right? Whether this MPC is big or small, right? Because remember the government want you to spend, right? And to forecast the income, let's say I want to forecast the income for the next period, I probably can look at how you spend, then I can see how much the consumption. So when designing policies or we want to forecast in the Y variable, you probably can look at in the individual axis. So this is why in empirical world, right, there are lots of studies trying to look at this MPC. Okay, and the consumption function. Okay, so now let's say this is what you want to do, your objective of your studies. You would like to look at a simple case relationship between the two, and you pay attention to the beta value. You want to find out this case. So your objective one is that you want to examine the MPC for Malaysian. Okay, so your objective one, let's say you are interested to look at this. You want to quantify the relationship, right? So is Malaysian spend more or they save more? Okay, so you want to know the spending behaviors, right, of the Malaysian. Okay, so now, how? So normally, right, of course, you're going to read the literatures, you're going to look at the sample data, okay? So try to get the sample data. So what sample data you need? You need the data on consumption, you need the data on income. So before you start to estimate this model, you probably would like to look at the data first lah. So one easy way to look at the behaviors of the data is to looking at the time plot lah. Okay, so let's say that you trying to look at the behaviors of the two series. Let's say you have the YY is your income and Y is your consumption, X will be your income lah. X will be your income. Okay, so now generate a simple time plot like this. What do you see from here is that you see that two series. All right, X is here, Y is here. You see that they tend to move together. Okay, so it seems that these two, right, being tied up together, right, how much you spend, how much you consume depends on how much money you have. From the time plot, it suggests or it gives you this kind of signal, but you know that the point here is that they seems to be co-move together. And also you see that both are showing you upward trending pattern. So our trending pattern is something that we don't want to see, am I right? And this is typically what you see in practice. Okay, so this upward trending pattern basically signal that the data X and Y, they are not stationary. There are stochastic trend inside there. Stochastic trend. In each of the series, X and Y. Okay, so this is what you see. So this kind of information, okay, you're going to use it. So when you want to quantify the relationship between the two, you need to take note on this kind of data pattern. Okay. So now this is what it says, right? So the consumption functions or the theory basically suggests that there is a relationship between consumption and income, right? And then let's say we have this regression. So you want to quantify this function using regression analysis. Okay, but just now what do we see? We see that there is an upward trending pattern. So we worried, okay, if we regression like this. Okay, given that your X and Y it show you a trending pattern, so you might want to worry about possibilities of spurious regression problem. So what is spurious regression problem? For any sets of variable, as long as they showing that you a similar pattern, I go up, you also go up. So we do not know this relationship or this co-movement, is it a genuine, is due to genuine relationship between the two variable, or it is a spurious regression? We do not know, because when you use OLS to estimate this beta value. OLS is a statistical tool. Statistical tools not able to tell you that the observed relationship, is it a genuine one or is it a spurious one or is it a fake one? We don't know. Just that we look at there is a common pattern there. Okay, so that is the things. So therefore, when you want to use time series data, that is the first thing that you have to alert yourself, right? This call movement can be due to a real relationship, or it can be a misleading relationship between the two. We don't know. Okay, so because once you see there is a trending pattern, it might blur your vision on discovering or detecting the genuine relationship. So this is what you see. All right, so what do? So we are interested, we know that we are interested to find out this MPC. Okay, but we concern more on the possibilities of spurious regression problem. So or else we think that you discover something meaningful, but it can be because of just by coincidence, these two variables, they move together. We don't know. Okay, so in practice, what do? So in practice, a common way is that we have to remove the non-stationary data. So remember in the previous topic, in level form. So if we see X and Y, they showing you upward trending pattern. So what do? First difference your series. So normally first differencing the series, okay, might remove some of the stochastic pattern there. So change in X, change in Y. Magnitude might be different, but you see that they are more stable. So what do you see? So normally this is what you do. Instead of level, you look at the first difference. And we call this a long run regression is simply because your data is purely looking at current period. What happened in the past, let's say t minus 1, t minus 2, y minus 1, y minus 2, all this lag term is not relevant when we talk about long run relationship, because what happened yesterday does not matter. Because if you're looking at the relationship, long run relationship between me and you, so what happened in the past, yesterday, last 2 days, will not jeopardize our relationship. So when you estimate long run regression, one easy way to identify whether it is a long run regression or short run regression is to look at whether there is a presence of lag value in your data or not. Okay, so long run regression implicitly assume that what happened in the past have no impact on our long-term relationship. So if yesterday I'm very angry with you, but because we are old friends already, it won't jeopardize our friendship. Am I right? So that is how you see these things. Okay, now because of this, right, you know that you want to estimate long-run relationship, but because of statistical reason, because of a time series properties reasoning, you have no choice but to first difference your series. So what is the consequence here? Okay, so when you first difference your series, so this is what we call a first difference model. Right, and this first difference model is no longer a long run model. For simple reason, because when we look at changes in Y, what does it mean? Y minus Y like 1. Changes in X, X minus X like 1. So in this case, whenever you have the lag coming in, which means what? What happened yesterday does matter. What happened yesterday will jeopardize the relationship between me and you. So therefore, okay, this number no longer equal to 0. So therefore, this first difference model become a short run model. Okay, so what happened? What happened here? So imagine that you're telling your supervisor this. Okay, you're telling it, okay, sir or miss, I want to estimate the consumption function of Malaysians so that I can predict their spending behaviors. Okay, so I'm interested to look at the relationship between Y and X. My objective number one, I want to find out MPC. How much is MPC by looking at the beta value here. Okay, that is your objective. You're the FYP1, you're telling this to your supervisor. But when it comes to FYP2, when you deal with the data set, you find that, problem. It seems that the data is not stationary. What do? I have no choice but to first differentiate my data. So I'm going to use equation 2 in my methodology. In my chapter 4, I'm going to estimate this. And then I try to pick up this value, alpha 1. So if this is the story, can you tell me that whether can you achieve the objective of this study or not? Remember, your objective is to study long-run relationship. But because of statistical reasoning, you have no choice. You can't estimate a long run. You have to tolerate with a short-run model. So what is the story here? Problem. So you might want, very likely you fail your FYP because what you promised is not being delivered. Because what you want to do is that you want to capture the MPC. And beta or alpha 2 here say nothing about MPC. This is not MPC. This is changes in the MPC. So in this case, there will be a problem. On one hand, you solve the statistical issue. You're trying to avoid spurious regression problem, but it leads you to another problem now, whereby you can't find what you want. Your long-run model now become a short-run model. Okay, so this is the problem you will encounter. Right, because first differencing will cut off your long-run information in the data. Okay, so long-run information will lost if you first difference your data. So this is not a good way lah. Even though you solve your statistical problem, but it doesn't really help you to answer your research question or achieve your research objective. So that is the common practice, common problem that we encounter in the 80s. Okay, when you're trying to study long-run relationship. Okay, so this is the problem. All right, so what is the solution? Okay, let's look at the solution here. So I'm going to introduce to you a new concept called co-integration that can help you to resolve this problem of finding long-run relationship. So from the theory, we already know that, okay, of course, definitely consumption is linearly related to your income, right? As reflected in your MPC. Okay, so, but due to statistical reason, you have no choice but to estimate a short run. So how do you go about this? It's pretty simple. Okay, so I'm going to introduce to you a concept called co-integration. What does it mean? Okay, the concept is very simple. All right, it basically deals with the stochastic trend in the data set. Okay, so remember when you look at relationship between two variables, so individually they have their own stochastic trend, right? Okay, so this one move outward, so this one trending upward, right? So X and Y, your consumption, and then you have your income, they moving towards a similar direction. Okay, so if there is a genuine relationship between these two, okay, what does it mean? It means that these two will have a co-movement over the years. These two variables, they will not deviate far away from each other. Okay, so economics, we call this a concept of convergence. Now you converge towards the long run. Okay, Now, this is what we call the concept of co-integration. Basically means that there is a genuine relationship between the two, long-run relationship or co-movement between the two. Okay, so this co-integration happens if our stochastic trend in Y, the stochastic trend in X, these two share a common stochastic trend. So both are sharing the same common pattern. Okay, so if there is a common stochastic trend between these two data, we say that, oh, there is a long-run relationship. There is a co-integration. There is a genuine relationship. Okay, so that is the concept of co-integration in a loose term. Okay, so that is the things. Now, here our basic understanding is very simple. Is there any genuine relationship between X and Y? It depends on whether the stochastic trend here, are they sharing a common stochastic trend or not? If it's common for both, then yes, there is a co-integration. So over the years, these two will move closely from one of another. They move together, right? And then they converge to the long-run relationship. Okay, if that is a common stochastic trend. Okay, versus the case. What happens if there is no co-integration? No co-integration basically means something like this. You have the X and Y. That over the years, the gap between you and me become larger and larger. So what you observe is here. It seems that they co-move together, but as time goes by, the distance between the two will be diverged from each other. This is no long-run relationship, no genuine relationship, no co-movement. Because the stochastic trend in X and stochastic trend in Y, they are different. They are having towards different destiny. They meant not to be together. Okay, so this is you and your wife. This is what you and your girlfriends. Okay, because temporarily you see in the short run, you seems to be very close to one another, but as time goes by destiny, she's not the one. So you will diverge far away from each other. This is no co-integration. So this is what I call spurious. There's no general relationship, right? If you're looking at this short term, the T will be very strong. But you know that as time goes by, you expand the time, you see that they will not. They are not meant to be for one of another's. So that is the things. So whether there is a long-run relationship between X and Y or not, it depends whether the individual common stochastic trend, is it common or not? It's common if they are sharing the same, means there is a co-integration, means there is a long-run relationship. If they are not sharing the same common path, they will diverge from one or another. Okay, so that is the basic concept here. So if for any meaningful long-run relationship, you should expect there is a co-integration between them. If there is a genuine long-run relationship, there must be a co-integration relationship between the two. Right? If the long-run relationship is spurious, then the stochastic trend will not be common. So there will be difference. Okay, now we know the concept. All right, question here. How do we know this relationship is genuine or not? Right? How do we know they are converging or diverging like this? Okay, so statistic-wise, it depends on the behaviors of the residue here, or the error term. So the behaviors of error term here will tell us whether the relationship between X and Y, they are genuine or they are spurious. Okay, whether your X is girlfriend or X is your wife. So it depends on the gap between you and the girl. Okay, so how do we do that? It's simple. Let's look at this. So these are two possible observation if you're looking at relationship between the two. Let's say, remember, we want to know, is there any relationship genuine or spurious? So it says that it depends on the gap lah. This is what the gap between X and Y. The distance between you and your girlfriend. So this, looking at this gap, look at this time plot. How the gap behave over time. So look at these two. What can you tell from here? So this is 0, right? Okay. And then you see the gap between the two over time. This is over time, right? So here is negative, near to 0, negative, near to 0, positive, negative, positive, negative. Sometimes negative, sometimes positive, sometimes negative, sometimes positive. But we know that whether it is negative or positive, it will not deviate far away from this constant bound, right? Okay, so you would like to look at, or you want to describe the behaviors of the residual here. This mimicking a stationary residual. Am I right? Okay, sometimes I angry with you. Sometimes I'm very in love with you, right? But over time, I cannot live without you. So the distance between you and me is 0. Okay, so if you see that the gap between two variables behave in a stationary way, you probably can say that X and Y, they are genuine relationship. They are co-integration. So this is one possibilities, right? It is also possible, you observe this case, B, whereby you study this, look at this. So this is the gap between X and Y, and you see that the gap between X and Y is positive, right? So, and this gap is increasing over time. There's no tendency to coming back to the 0, which means that the difference between you and your girlfriend is getting bigger and bigger over time. You are not meant for each other. So this is no co-integration. So this no co-integration, huh? No co-integration. No long-run relationship. So if you regress regression like this, you regress regression X and Y, right? For this, you see that this will be spurious, right? P is high, R squared is high, right? Magnitude is high, but you can't trust. Cannot trust this result because there is no long-run relationship. Okay, so if there is a theory to support, okay, if there is a theory underlying your model, most likely it is a genuine case, and you will possibility to get this co-integration relationship. Okay, what we afraid most is you randomly choose X and Y. You build your model without any theory. No sense one. You just, residual A say X, residual B say Y, and then you try to combine together. There's no mechanism behind, there's no rationale behind. You just pick two paper and then you combine. So what we worry is you will get this case whereby your regression is very beautiful. It might give you a misleading result. And then you draw your wrong inferences. So this is what we don't want to see. This is what we want. We want that there's how the the residual between the two is a stationary pattern. So what we worry is that when the gap between X and Y is non-stationary over time, it can be increasing or decreasing. Definitely, as long as there is a gap and the gap is increasing or changing over time. So this is the things that we worry. Okay, so if you get version A, means that your long run regression is not spurious. If you get result version B, then your long run regression is spurious. You cannot use this model. So version A, yes, you can use the long run regression. No issue. You can draw inferences. You can pick up the MPC. This one MPC cannot be used if you have this situation. So that is the implications of for integration in regression analysis. Okay, so now try to synthesize all these things. Okay, so here we are trying to introduce you a concept called co-integration. And we know what co-integration is basically means long-run relationship. And this long-run relationship is a genuine one. There is a co-movement between the two series. Okay. And when we say there is a co-integration between two or more non-stationary series, it basically implies that there is a long-run equilibrium. Long-run equilibrium means what? Both are converging towards the same direction. Okay, so they move together in such a way that their linear combination result in a stationary series. So what does it mean? It means something like this. Y, X, stochastic trend, but the linear combination, this is what we call linear combinations of X and Y, they are stationary. This is what we see. This is implied co-integration. If X is like this, Y is like this, X is like this, linear combination and like this, then this is no co-integration. That is the concept lah. Right. So this basically implies that the stochastic trend is not common. This implies that the stochastic trend between X and Y, they are common. They are sharing a common stochastic trend. That is the rough concept of underlying this co-integration. Okay, so of course, statistically, we can define co-integration as such. Okay, so Engel and Granger define co-integration in from statistical point of view. So if you see, if X, if X, if X and Y, they are co-in, they must fulfill two conditions. First, the stochastic trend must be same order. So if Y is I1, X must be I1. Okay, so and then the linear combination between the two, right? There is at least one coefficient factor. Coefficient vector means what? Coefficient vector means this. This beta value. Okay. First condition, these two must have the same order of integration. And there is second condition, and that these two are tied together by this beta value. We call this a vector of co-integration. Okay, whereby the linear combination is one order lower. This implies what? If this is I1, this is I1, this will be I0. Then we say X and Y is co-integration. If this is I2, this must be I2, and then this must be one order lower. We say that there is a co-integration. All right. Now, what if it is I1, I0? If this is I0, this is I0. So this stationary already, this stationary already. So in this case, no need to do co-integration. You can directly estimate this because it fulfill the assumption already. There's no need for you to carry out co-integration test. So what we worry is the case 1 and case 2, whereby your order of integration is not 0, it's more than 1. Okay, so that is the statistical term between the two. Right. Okay, so that is our key focus number 1. Let's move on. All right, so these are some key points that explain the previous slide. This is what it basically means. This slide is to explain this one. All right, so that is the first half of our discussion on what is co-integration about. Okay, next one is we want to look at how do you detect this co-integration. So in the empirical work, there are 2 approaches. First is what I call the single equation approach. Second one is what we call the system equation approach. So we are going to learn these 2 approaches. So in this topic, we are going to look at this simple residual-based Engel-Granger test. And then I want to introduce you to another single equation approach on Engel-Granger ECM approach. Okay, so the key difference between these 2, this can help us to detect long-run relationship. So they will tell us yes or no. Is there any long-run relationship or not? Yes or no. Okay, so the second one is what I call the Engel-Granger 2-step error correction model. So this error correction model, it tells us yes or no. We can also model the short run and long run. Okay, so that is the key difference. Right, there's another one that is not in our syllabus. It's what I call the ARDL bound test approach. Okay, so it works very similar with this, but the test statistic used are different. Okay, it is introduced by Pasaran. Okay, and then it basically based on this classical approach. This is a improved version of the classical ECM model that we call this ARDL bound test. So unfortunately, we didn't cover this in our syllabus. So I think some of you might use this for your FYP, but if you understand the second one, the third one will be very easy. Okay, because the principle used are basically very similar. Okay, so that is a single equation approach. The other one is what I call system equation approach. So this one we will cover in topic 7. So that is the things. Okay, so how do you conduct Engel-Granger co-integration test? Very simple. If you understand the principle behind, then you know that to conduct this is very simple. So Engel-Granger co-integration test basically involves 2 steps. Step 1 is to estimate this long-run regression, and we call this long-run regression. This one is 1. Long-run regression as co-integrating relationship. So this is your long-run regression. So suppose that you look at your consumption and your income. Okay, so you are looking at this. So try to examine these things first. make sure it is I1. This is I1. And then if co-integration happen, you should expect this should be I0. So step 1 is to estimate this long run relationship. Second one is to study the behaviors of your residual term. Okay, save the residual and then perform the augmented Dickey-Fuller test on the error term. So you are paying attention to the gamma here. Okay, remember gamma lesser than 0, more than 0. So this is uniroot. This is stationary. Okay, so if reject hash node means X and Y, they are co-integrated. If do not reject means what? They are not co-integrated. Very simple. Oh, so that is the called the Engel-Granger test. All right, this is the step law. So you are looking at equal to 0, not lesser than 0. Okay, so you calculate the tau statistic, all right, and then you see whether the null can be rejected or not. Okay. Okay, so a finding of co-integration implies that there is a general relationship. A finding of no co-integration means what? The long run regression is not applicable. So you have to estimate short run. Okay, so what is the benefit of finding a co-integration? So what is the implication of regression analysis? Implications of regression analysis implication of co-integration in regression analysis, right? So if you find or you manage to find co-integration, actually this is a good news. Okay, why? Because it has an implication on our regression analysis lah. Okay, so first, co-integration basically embeds the long run concept. Okay, so if you're studying any theories, you wanted to see whether the theories still hold today. Okay, the presence of co-integration imply that okay, it is relevant. So concept-wise, co-integration mimicking the long run concept that you want to study. Okay, so if there is a co-integration, we can safely say that there is a long run relationship exists. Okay, so the usefulness of finding co-integration basically implies there is a long run relationship. So when you see the residue is stationary, you can safely say that, oh, okay, X and Y, they are co-integration. So this is concept-wise, how this statistical concept of co-integration assists us in understand the real world. Because we always wanted to know or we wanted to detect long run relationship, and co-integration offer us one simple way to detect the long run relationship. Okay, so benefit number 1. So co-integration imply long run relationship. Now statistical wise, okay, what are the benefits that you enjoy if you see there is a co-integration between X and Y? Okay, so firstly is try to help us to deal with non-stationarities of data. So we know that in the beautiful world, we need to assume X and Y is like this. But unfortunately, in practice, what do we see? They are non-stationary. So when you have non-stationary series, to finding long-run relationship is very challenging because of the possibilities of spurious regression problem. Okay, however, if you see there is a co-integration between X and Y, regress non-stationary X and regress on Y will not be spurious, because there is a general relationship. So this is another benefit of having co-integration. It allows us to analyze non-stationary data. Okay, and of course, it clarifies the spurious regression problem. As long as there is a co-integration, long-run regression will not be spurious. Right. In fact, another benefit that you see, if there is a co-integration between X and Y, the OLS that you estimate, that you use to estimate the beta value, the OLS, what is the properties of OLS? If all the assumptions fulfill, your OLS will enjoy a good benefit, right? Whereby your OLS is unbiased, efficient, and consistent. Okay, so if assumption fulfill, if this is stationary, your OLS will be unbiased, efficient, and consistent. Now, if this is non-stationary, but there is a co-integration, you will see that the OLS estimates of beta, not only that they are unbiased, efficient, and consistent, they are super consistent, even better. So what is the difference between consistent and super consistent? This is just like asking you, what is the difference between man and Superman? Right? So this will be another better, even better qualities. Right? Super consistent means what? Consistent means something like this. If your sample size increase, your sample estimate of beta will converge to the true value of beta. So your sample estimates will close to your population estimate. This is what I call consistent. Now, super consistent means what? Super consistent deal with the speed, because the difference between man and Superman is the speed, right? Okay, so now if there are co-integration exists between X and Y, your beta estimate, not only that they are consistent, they are super consistent. Meaning to say what? If your sample size increase, your sample estimate converge to the true value at a much faster rate than the stationary X and Y. Or compare two cases. Case number 1, X and Y, stationary. So OLS consistent only. Right. Case number 2, non-stationary, but there is a co-integration. Your OLS will be super consistent, even better. So that is the concept-wise. So the benefit that you enjoy if you manage to detect co-integration between the two. All right, so consequently, we can estimate this simple static regression now, even though the X and Y is not stationary. Okay. Furthermore, another two advantages is that, furthermore, if there is a co-integration between the two, econometric problem, like for example, omit dynamic term, or there is an endogeneity problem in this regression, all this can be ignored if your sample size is big enough. So asymptotical means what? Big sample size, very big. Okay, so first we look at dynamic misspecification. Dynamic misspecification means we omit dynamic term in the model. Dynamic means what? Changes. Changes means what? Short run. So suppose that the relationship between X and Y is not long run yet. it is short run. We are heading towards long run, but not yet long run. We are becoming husband and wife at the end of the day, but now not yet. So if girlfriend means what? You treat them differently, right? So what happened yesterday, last 2 days does matter. Will influence the relationship between you and your girlfriend, am I right? Okay, so what happened if the relationship between X and Y is not yet long run, but heading towards long run? So you want to look at the current situation. So current situation means what? The short run model will imply that this dynamic term is not equal to 0. What happened yesterday or last 2 days doesn't matter. How you behave yesterday or last 2 days will have an impact on you and your girlfriend. So in this case, this is what we call the dynamic term. By right, you should use this dynamic model. But because of your assumption or your ignorance, you believe that your relationship is strong enough, you are in long run already. So this is the population, but you estimate sample like this, using sample like this. So what will happen? All this dynamic term being omitted. So where it go? It go to your error term lah. It will make your error term suffer from autocorrelation problem. Omit important variable. What important variable is that? Dynamic term. By right, you should add dynamic term in your model because you are not yet long run. You are heading toward long run, but not yet long run. By right, you should include the lag model inside, lag variable inside. But you didn't. So what happened? The impact will absorb by the residual, and residual will tend to be correlated. So that is what we call dynamic misspecification. So endogeneity means what? Endogeneity is another problem. Endogeneity problem. Meaning to say what? You write your regression like this. So this is your model. So looking at this relationship between you and your girlfriend, this is you. This is your girlfriend. So in this relationship is not symmetry. It is asymmetry. Means what? Someone play more important role in this relationship. Who? The one on the right-hand side. Because X is independent variable. How much you will feel depends on how much X feel. Right? So this is what we call the relationship between the two, and X is the boss because X is the independent variable. Okay, so when you form relationship or construct model, you have to determine who is on the left-hand side or who is on the right-hand side. So in this case, you assume that girlfriend is the boss. She is the one that determine the relationship between you and the girlfriend. This is the model. Now, what if in the reality, X is depend on Y? So which means what? What error you conduct, you wrongly put or wrongly define who is dependent, who is independent. So this is what I call endogeneity problem. You will wrongly define who is X or who is Y. Your regression will suffer from endogeneity problem. Endo means left-hand side. Endogeneity problem means what? You put the wrong person on the left-hand side. Okay, so these are two very serious econometric problems. All this will lead to autocorrelation problem. Okay, now the good news is that if there is a co-integration between these two variables, econometric problem like this and like this can be directly ignored. Okay, so when you go to FYP presentation, your examiner asks you, okay, I think your model, you have omit important variable. I think that you have the endogeneity problem. So you say, oh, it's okay because we managed to detect there is a long run relationship, there is a co-integration relationship. And given that our sample size is relatively big, so all this econometric problem can be directly ignored. So that is a good implication of finding co-integration. Oh, see, simple concepts have big impact on analysis. Okay. All right. So why is this not a problem? Because your OLS is not only consistent, they are super consistent. But we have to take note lah. This happen if and only if your sample is big enough. Right? If your sample size is small, you might have to ponder about this. How do you know whether your sample size is big or small? Very simple. What you do in practice is that you try to estimate this. And then check there is a coin or not. Then reverse it. Check is there any co-integration or not. If reversing the position, let's say this one, yes, there is coin, but this one say no, there is coin. This one means what? Your sample size is signal that your sample size is not big enough lah. So changing the position will change the result. So something that you have to worry about, that your sample size is not big enough. Okay. So furthermore, all right, coefficient can be biased now, because still you will see autocorrelation problem. Okay, and this impact of autocorrelation problem cannot be ignored if your sample size is small, right? And the biasness in your long run regression also relates to your R square lah. So a high R square will generally indicate that the bias will be smaller. So in this case, these are some of the things that background check on your result and see. Okay, so there you go. All right. Lastly, another implication of co-integration is expressed by this, what we call a Granger representation theorem. Okay, so this Granger representation theorem basically says what? Simple law. It says if there is a co-integration between X and Y, the best way to model X and Y is to use ECM model. So what is ECM model? ECM model is what I call error correction model. So what is the benefit of using error correction model? This can capture the long run plus short run model. Remember just now we worried about omit dynamic term, the short run effects being ignored. Okay, especially when your sample size is small, you might worry, right? So this can be easily overcome by considering the second approach, which is the error corrections model approach in detecting the co-integration. Okay, so this will be much more useful when your sample size is relatively small. Okay, so that is the implication. All right, so Ken? So far we have covered 2 sessions. So first on the concept, secondly on how do you detect, and then we look at the implication. Okay, so last part is the error correction term or error correction model, right? So I think I will reserve this this part in our next lectures lah. Oh, this is a bit technical. I need more time to explain this to you. So this part I think we will continue in week 12. Okay, so basically this is what we are going to cover today. Any questions so far? Your brain later overheated. Okay, so is there any question from your side or anything that you want to ask? So if not, then I think we can conclude here. Oh, let me stop the recording.